Hi there, and welcome to another video tutorial. For today's lesson, we will be discussing about plate tectonics. But before proceeding to this video, let us go over with the following learning competencies for us to be guided with this lesson. First, describe and relate the distribution of active volcanoes, earthquake, epicenters, and major mountain belts to plate tectonic theory. Second, describe the different types of plate boundaries. Third, explain the different processes that occur along the plate boundaries. Fourth, describe the possible causes of plate movements. And the fifth one, enumerate the lines of evidence that support the plate movement. As a general reminder, take note that you can supplement yourself with other learning materials using the other platforms, including the printed learning kits. You can also write down your thoughts to help you in processing information. Also, keep in mind that your success in this lesson depends on how much effort you put into doing the activities provided in this lesson. And of course, you can also pause, go back, and view again this video lesson if you find it necessary to do so. This is to hope that we will be hand in hand as we face this new normal, as I help you to become self-directed, independent, goal-oriented and self-regulated learners. Now, are you ready? Let's get started. Our country, the Philippines, is blessed with so many land features, such as mountains and volcanoes. These features can be sources of different minerals, or can be used for agricultural purposes. For example, we got the magnificent and world-renowned Mayun volcano. Due to its activity, it produces fertile slopes and plains used by local people to grow their crops. In the northeastern part of Bohol, we have the Binabaji Hills, which is an incredible ridgeline, overlooking, and a stunning mountain range of the Alicia Panoramic Park, and the home of many endemic species of flora and fauna. Have you ever wondered why our country is endowed with these kind of geologic features? Well, if your answer is yes, then this module will help you find the answer to your question. In this module, we will study the theory of plate tectonics, which describes the events within the Earth that gives rise to mountain ranges, volcanoes, earthquake belts, and other features of the Earth's surface. At the end of this lesson, you are expected to answer the key question: what is the relationship among the locations of volcanoes, earthquakes, epicenters, and mountain ranges? Alright, let's start with the major layers of the Earth, which includes the crust, the mantle and the core. Let's try to recall what you have previously learned about these layers. Starting with the crust. The crust is the topmost layer of the Earth. It consists of the continental crust and the oceanic crust. Now, let's try to differentiate the differences between the two. The continental crust consists mainly of granite-type rocks, which is about 50 to 100 kilometers thick. And they are around 3.8 billion years old. Meanwhile, oceanic crust consists mainly of basaltic rocks. They are around 5 to 8 kilometers thick, and is around 200 million years old. Up next is the second major layer of the Earth, and that is the mantle. The mantle is considered as the thickest layer of the Earth. It can be subdivided into upper and lower mantle. Mantle is also about 2,885 kilometers thick. And the third major layer of the Earth is the core. The core is the innermost part of the Earth. It consists mostly of iron and nickel. And it is further subdivided into liquid outer core and solid inner core. I know you also heard the word lithosphere and asthenosphere. Let's try to differentiate the two. The lithosphere is the rigid outer layer of the Earth. It includes the crust and the uppermost mantle, while the asthenosphere lies or is located below the lithosphere and the uppermost mantle. While the asthenosphere comes from the Greek word asthenes, which means weak. It is where the convection of hot, weak, molten, and easily deformed rock happens. Let us now proceed to the boundaries between the Earth's layer. In this video, we will only focus on the two, namely, Mohorovicic discontinuity and the Gutenberg discontinuity. Mohorovicic discontinuity separates the crust and mantle. It was named after the geophysicist Andrea Mohorovicic. According to him, velocity of seismic wave arises from the change in density of the rock. On the other hand, the Gutenberg discontinuity divides the mantle and the outer core. It was named after Benno Gutenberg, who was a German seismologist. Gutenberg observed that P waves diminish and die out completely when they are about 105 degrees from an earthquake, but reappear about 2 minutes when they are 142 degrees away. This region where a direct seismic wave is absent, which covers an arc of about 37 degrees, this is the result after we subtract 142 degrees by 105 degrees, and this region is called the P wave shadow zone. This time, let's now proceed to the theories about the changes in the lithosphere. We have 3 theories that we'll be mentioning in this video, namely, the continental drift theory, the theory of seafloor spreading, and the plate tectonics theory. Let us try to discuss them one by one. Let's start with the continental drift theory. In 1912, Alfred L. Wegener, a German geophysicist and meteorologist, proposed the continental drift theory. He said that the continents were once joined together in one supercontinent, called Pangaea, a Greek word which means "O land." Wegener's theory was published in a book entitled The Origin of Continents and Oceans. Pangaea was a supercontinent that existed during the late Paleozoic and early Mesozoic eras. In contrast to the present Earth and its distribution of continental mass, much of Pangaea was in the southern hemisphere and surrounded by a superocean called Pampelassa. Now, how did Wegener arrive at this idea? First, the coastlines of the continents fit together like a jigsaw puzzle. Notice that the east coast of South America seems to fit the west coast of Africa. Next, identical fossils of organisms were discovered on different continents, suggesting that a land connection between continents was probably present in the past. Lastly, certain continents share common geological features, such as mountain ranges, rock types, minerals, and resources. The continental drift hypothesis was subjected to criticism because the idea failed to explain the driving forces necessary for the drift or separation to occur. The second theory is the theory on seafloor spreading. The theory on seafloor spreading is the mechanism by which new or young seafloor are constantly being created at mid-ocean ridges, while older parts are pushed away from the ridge. This theory, introduced by Harry Hess, was proven as patterns of magnetic field polarity preserved in seafloor basalt, and by age dating of the rocks. And the last theory, about the changes in the lithosphere, is the plate tectonics theory. This theory suggests that Earth's crust is broken up into several deep-moving land masses, which are believed to be brought about by convection currents within the mantle. Tectonics, from the Greek word tektonikos, which means construction. As you can see, we have here the different plates such as the Pacific Plate, North American Plate, South American Plate, African Plate, Eurasian Plate, Australian Plate, and the Philippine Plate. I hope you learned something from this video. Until next time.